Hi, I'm the Texaco Tanker man, and today I'll talk about restoring the tanker's electrical system. In a previous video, I showed how to disassemble the tanker, so I'll assume here that you already have access to the parts inside it. It's a pretty simple system. What could go wrong? Let us count the ways. But first, a quick description. Two D-cell batteries are installed between the contacts shown on the right. Both cells are installed positive side up, or in parallel, so it is a 1.5 volt system. By the way, the heavy batteries are a part of the tanker's ballast system. The positive wire goes straight back to the motor, while the negative wire leads to a simple toggle switch for on-off operation. Both installed the same way? Already we have an opportunity for errors. I found this example where one cell was installed backwards for the last 65 years. Not good, and a lot of damage was done. But even when installed correctly, batteries left in any device can leak, which also causes damage. WinMac tells us how to install the batteries, but the text is small. So let's zoom in on it. The contacts are made from phosphor bronze, which is commonly used in many electrical devices. It is hard and springy, and doesn't oxidize as quickly as brass or plain copper. But it does oxidize, and parts may require cleaning to restore function. Here we have an original set of contacts in good condition, sitting in the white plastic house. At the lower left is all that remains after years of battery corrosion. At the lower right is a pair of new contact blanks I had laser cut as replacements. There can also be problems with the contacts mounting. Corroded screws can make it hard to remove the lower contact, and the small peg for the upper contact can break off. The simple toggle switch does not use phosphor bronze, but has plain brass contacts instead. They can become heavily oxidized, and then the system cannot be turned on. The motor housing may get corroded, but that is usually not a functional problem. But its brushes and commutator can oxidize, and the bearings can get gummed up. Also, it is very common to find poorly soldered wires at the contact plate. The wires themselves can cause problems. It is common for the ends at the solder joints to fatigue and break off, and the insulation gets rock hard. This lack of flexibility can contribute to strain on those wire ends. So what to do about all these problems? We'll start with the contacts. Hopefully, yours are in salvageable condition, because my replacement parts are currently unavailable. I do hope to get more in the future. But if you can just clean yours up, that will be the best. I soak lightly corroded contacts in Brasso, and follow up with mechanical polishing if needed. For the upper contact, I desolder the wire for easier handling of the house. Try not to remove the contact from the house, as it is so easy to break the peg off. If the peg does break, you can drill out the boss to accept a number 4 or a 3 mm screw, which is how I mounted this replacement contact. From above, countersink the hole for a flathead screw so that the wheelhouse deck can be installed over it. For the wires, you can opt to replace them with modern and more flexible wires, or keep them as is. You will want to check each connection for frayed wires. Restrip and resolder as needed. Here's the wiring diagram again. Note that I don't show the actual wire routing. At the motor, the wires were routed up and through the motor mount housing, but they don't need to be. You can route them forward as shown, but make sure that the wires don't foul on any mounting features. In particular, there is a long boss inside the aft house which rests on top of the motor mount. Let's fix this switch. Its main problem is oxidation on the contacts. Here we have the switch's front and back sides, and a view with the steel cover removed. Note that the tabs on the cover can be bent back and forth only a few times before breaking off. On the uncovered switch, the exposed wire is soldered onto a brass eyelet on the toggle. I have experimented with cutting off the center aluminum rivet, and replacing it with a nut and screw. I found that there is no need to do this, but this part shows us the stationary brass contact and the toggle's eyelet which sweeps off and back onto the contact. We can clean these without disassembly like this. So we start with a virgin switch. Use a tool to lift the tabs. And carefully pry the steel cover off. Now use an electrical contact cleaner like Deoxit. Work a drop of cleaner into the contacts, and sweep the toggle back and forth a number of times. Test the switch before replacing the cover. You can use an ohm meter, or connect 1.5 volts and test with a working motor. And what about fixing a dead motor? This example looks to be in good condition, but nothing happened when 1.5 volts was applied. You can also see that one wire has fallen off, due to a cold solder joint, which is a common problem. I use a bench power supply for testing motors, but any 1.5-volt battery fitted with test leads will work. Your motor may have exterior corrosion, but this is only cosmetic. If you must take your motor apart for restoration, mark the magnets first so they can be reassembled correctly. There are many more wrong ways than right ways possible. Also note the thrust washer's locations. For most motors, only the brush plate needs to come off. Some motor trivia: these motors were made with two different bearing sizes, 1/4 inch OD and 3/16 inch OD. The correct motor mount must be used with each. It is possible to get the brush plate off without removing the motor from the motor mount. If you must remove the mount, you can carefully work its halves apart with a sturdy knife or chisel. Move around the mount's 3 bosses and pry the halves apart bit by bit. Dag nabbit, I broke 2 pins anyway. Broken pins can be repaired with 1/8 inch styrene rod and number 4 screws. Styrene model cement can be used. Let's have a look at the motor. This is the bottom side. The output end is marked TKK, the company's name prior to its becoming Mabuchi Motors. Here are the top and starboard sides, where we find the brush plate. This is how I received this motor, and it is clear that someone has already lifted the tabs to service the brushes. Note that the tabs on the aluminum case can only be bent a few times before breaking, so avoid unnecessary work here. Lift the tabs and work the brush plate loose. The brushes are simple phosphor bronze stampings that ride on the commutator. Just as with the switch contacts, we will use deoxit contact cleaner. The cleaner comes with little swabs for reaching inside parts. Wipe inside the brushes, taking care not to alter their shape. Then wipe the commutator until clean. It is not recommended, but I have sometimes also polished the commutator with very fine emery sticks. The bearings can dry out or get gummy, so we will apply a tiny drop to each. Use sewing machine or 3-in-1 oil. Just a tiny drop. Replace the brush plate but don't close the tabs yet. Ensure the plate is seated and then apply 1.5 volts to test the motor. You may need to spin the shaft by hand to get it started. Once it starts, allow it to run in for a bit. Secure the brush plate tabs. Next, I needed to repair the cold solder joint. Here I have used a blade to scrape the solder pad clean. Pick up a little electrical solder on the tip of your iron and apply it to the solder pad. Make sure the solder has wetted the pad. Pre-tin the wire end with solder, and then solder the wire to the pad. Test the motor and switch together, and then you will be ready to reinstall the refreshed electrical system into your tanker. Congratulations! Here again is the wiring diagram. For the correct motor rotation, make sure that the positive wire is attached to the lower solder pad on the motor. Thanks for watching, and I invite you to check out my Texaco Tanker service parts on eBay.